today we are getting into 2.4, which talks about modeling quadratic equations. In other words, using quadratic equations for real things. Your favorite things in the world, word problems. But it's not just word problems. We are dealing with regression problems. We've dealt with regressions before. We dealt with linear regressions back in chapter 1. Today, they're not linear. They're quadratic. So, do you remember back in chapter 1 when I gave you a list of data, x's and y's, and I said, put it into the calculator? Guess what? That's what we're doing. Where do I go in my calculator to enter this data in? What menu? The statistics menu. So, if you have a TI, there's a stat button. If you have a Casio, you go back to your main menu, and then stat is the second option. Now, when I bring it up on my Casio, it goes directly into lists. How do I get to the lists on the TI? Edit. Now, keep in mind, before I go any further, you need to know how to do this. I'm not going to tell you how to do it every single time. So, we got to remember these steps. Now, I've got things in my lists. How do I get rid of those things? You could just click delete a bunch of times and it'll do it. On the TI, you can also scroll up to the name, click clear, and enter. On the Casio, if you use F6 to scroll over, there's eventually a del A or a delete all option. I don't care how you delete them. Just make sure you don't delete the actual list itself on the TI. Now this first problem that we are given says the table shows the fuel efficiency of a vehicle at different speeds. Determine what type of function you can use to model the data. So, in other words, it's not necessarily quadratic. It might be something else, and we have to figure out what it is. Easiest way to figure it out? Make the calculator tell us. Start by plugging in your x's and plugging in your y's. Remember, your x's go in list 1, your y's go in list 2. While a couple people are still typing in. Is there anyone that does not know how to type them in? So one of the things that we talked about back in chapter 1 is we talked about how you could tell just how good of a linear equation you had by looking at R. R was our correlation coefficient. I told you to kind of think of it as a percentage written as a decimal. The closer it is to 1, the better the linear regression it is. Now, that's specifically for linear. When we start wanting to compare different functions, when we're trying to determine, is this a better linear, is it a better quadratic, we have other tools to our that are available to us. Now, one of the things you technically can do is you can technically look at a graph of all these coordinate points and ask yourself, what shape does the graph give? Now, on Casios, that's pretty straightforward to do. On TIs, it's kind of bulky, and there's a better way in the first place. And that is, when we did our linear regressions, there was not only R on screen, there was also A and B and one other thing. Do you remember what that fourth thing that showed up on screen was? R squared. R squared is used to compare with nonlinear functions. That's why they gave you R squared. So if we want to compare if a function works better as quadratic versus linear, that's where that comes into play. Okay, I've got my data in my calculator. I am going to look at the different types of regressions and figure out which one is a better fit. How did we do a linear regression again? What buttons do I click?
We don't.
You should. For the TIs, you click stat. And you are calculating a regression. And then you had a bunch of different regressions to choose from. For the Casios, you don't have to click stat. You just start with calc. It should show up on the bottom of your screen. Do you see calc on the bottom of my screen?
Yeah.
You do?
No.
There's a glare.
Oh, okay. If there's a glare, that would make it really hard to see. If calc is not on the bottom of the screen, for the Casios, you got two options on how to get it there. Either you're in a menu and click exit. If exit does nothing, the other option is you're just too far into the menu. How do I scroll in these menus? F6. Do you see calc now?
Indeed.
Calc. Now, what type of thing am I doing? 1 var, 2 var, a reg? A regression. Now, here is where yours gives all the options of the different types of regressions. So far, we've done linear regressions, which for the TI is lin reg, question 4. For the Casio, a linear regression is, well, what type of equations are linear? What do they have for variables? Do they have x to the fourths or x to the thirds or x squareds? Do they have a med in them or do they have x's? They have regular x's. So, we click the x. And then we do the ax plus b option. So, on the TI-84s, it gives me a bunch of options here, but generally speaking, we are always just using list 1 and list 2 and not using a frequency list. My two calculators give me the exact same information. This one gives me one more piece that I have no earthly idea what it is. So, we are still trying to determine what type of function it is. So, for linear, our r squared was 0. I would go to 3 or 4 decimal places. 9, 5, 4, 8. Okay. That would be if it was linear. Now you could still kind of think of these as percentages. They're not actually percentages, but would that be a pretty decent linear regression? Yeah, but I'm trying to see if linear is actually the way to go. So, once I have that information down, I'm going to get out of this for now. So I'm going to clear on my TI or exit on my Casio, and I'm going to double check if it should be linear. Because another type of regression we can do is a quadratic regression. So, on my TI, I've already got the data typed in, so I'm going to go over to stat and calculate again. On the Casio, I'm currently in the linear regression menu, so I'm going to click exit to back out of it a little bit. Which of these would be quadratic? X squareds. Which of these would be quadratic? The one that says quadrag. The Casio brings it right up. The quadratic one, the TI, tends to give me this list again. If you've got a TI-83, you just click enter. Okay. when it was quadratic, r squared was 0.9995. If we think of them as percentages, which one's better? Quadratic. So, determine the type of function that we can use to model this. Quadratic. R squared is closer to 1. Once we have that, it says write a function that models the data. In other words, write an equation. Isn't that kind of the point of a regression, that it writes an equation for you? Yes. It tells me my equation is in the form of y equals ax squared plus bx plus c. Do you know what a, b, and c are? Do we know what x is? No, but are we supposed to know x is a number, or is x stay x? X stays x. Y equals, round to at least 2 decimal places. Rounding a to 2 decimal places, it should be negative 0.01 x squared. Plus bx, so plus 1.39 x. Plus c, which is negative 7.51. Use the model to approximate the best gas mileage. Here's where understanding a little bit about what the word problem wants is an important thing. When you're talking about gas mileage, what do you want? Higher numbers, lower numbers? Higher. You want more miles per gallon. Okay, miles per gallon is which of our variables? I heard 2 different things. That's why. Gas mileage so that's just a little note to myself that the y is the miles per gallon. I want it to be the best, so I want it to be the highest possible amount. In other words, I'm looking for the highest y value. When you talk about a quadratic equation, how can you find the highest y value? What is the highest part of a quadratic equation known as? The vertex. The highest or lowest point on a quadratic equation is that vertex point. How do I know it's the highest point on this one? How do we know that the vertex would be the highest point on this quadratic equation? Because a is negative. If a is negative, it flipped upside down. This brings all of that information together. So, I need to find my vertex. What form is this equation in? Is that vertex form, intercept form, or standard form? It writes it in standard form. And in standard form, if I want to find the vertex, I first have to find the axis of symmetry. X equals, what's the formula for the axis of symmetry in standard form? Those are my 3 equations that we have for axis of symmetry. Standard form. Does standard form have H, P's and Q's, or A's and B's? A's and B's. It's opposite of B over 2A. This is A. This is B. This is C. So when I do negative B over 2A, negative 1.39 over 2 times negative 0.01. Negative 1.39 is getting divided by negative 0.02 if I multiply those. Y'all got a calculator. What do you get? Not that big of a number. Bigger number? Sure. Y'all got calculators. What do you get? You're literally typing in a divide. Thank you. I get 69.5. Now that is the x value of the vertex. Do I want the x value for the actual mileage? No, remember mileage is miles per gallon. You want higher miles per gallon? And that's y. The y value is what I'm looking for. If I have an x value and I have an equation, can I find the y value by plugging in x? I need the x, but I don't want it as a final answer, is what I meant. Negative 0.01, plugging in 69.5 squared, plus 1.39, plugging in 69.5, minus 7.51. At 69.5 miles per hour, the best mileage is 40.7925 miles per gallon. It's actually really good miles per gallon. Other questions are going to be slightly different, but they're all going to be very similar in idea. NASA can create a weightless environment by flying a plane at a specific path. The table shows the height in feet of the plane t seconds after starting the flight path. After 20.8 seconds, passengers begin to feel weightless. Determine the type of function that you can use to model the data. Okay, this brings it back. What did we use to determine which was the best option? How did we start the problem? By plugging the numbers into our stat menu. After I plug in all the data, I do my regressions, and I'm starting by looking at what part of the regressions. R squared. So, since I'm working on my TI, I go to Stat, over to Calculate. I'm going to do both linear and quadratic, because those are the only ones we've talked about so far. For linear, r squared is 0.7126. Is that a great linear regression? No, it's not great. Maybe quad is better. How's quad? If r squared is 1. Closer it is to 1, the better it is. If it's exactly 1, that means it's a perfect regression. That means if I were to make this equation, it would hit every single point perfectly. So, which one's better? Quadratic. R squared is closer to 1. You're explaining your reasoning isn't exactly deep for this one. It's which one is r squared closer to 1. Write a function. When it asks me to write a function, I'm just using what the calculator told me. It tells me my equation is y equals ax squared plus bx plus c, where a is negative 11, b is 700, and c is 21,000. Big numbers. Now, there's one tiny little glitch we got going on here, and it's not actually a glitch, it's just one issue. What variables does this problem use? Nope. That's the form uses a, b, and c. It uses t and h of t. So in all actuality, this should say h of t is equal to a negative 11t squared plus 700t plus 21,000. That being said, I don't care if you write down x's and y's. But it uses t and h of t, so that's technically what it should be. Just know the first letter corresponds with the x's, the first column. The second one corresponds with the y's. Evaluate the function to approximate the height at which weightlessness would occur. What did it tell us about weightlessness above? It happens at 20.8 seconds. What variable would that be? T. Guess what? If I want to find the height, and I have the time, and I have a formula, what am I going to do with it? Plug it in. You will start to experience weightlessness at 30,800.96 feet. But there's one thing you have to keep in mind, and it has to do with the final question. What is the initial height of the plane? Because it didn't start at 0. In this scenario, the initial height is not like from the ground at takeoff. It's from when they start this maneuver to get weightlessness to happen. I want to find the initial height. When you do something initially, when are you doing it? What was that? Then. Okay. Need a little bit more. Now is not the time. you do something initially, you do it at the start. Time-wise, when is the start? 0. Initial means time is equal to 0. Your initial height, your initial anything is also known as the y-intercept. And at the y-intercept, your input, your x, or in this case t, is 0. If I know time is 0 and I have an equation, how can I find the height? Plug in 0. But this is in standard form. And in standard form, when I plug in zeros, the only thing that is ever going to be left is C. This maneuver started at 21,000 feet. Now, we could keep going and do more examples like this, but for the most part, this is what the examples are. Type it into your calculator, do a linear regression and a quadratic regression, compare r squared. Which one is a better r squared tells you if it's linear or quadratic. If it's quadratic, write down the quadratic equation. If it's a linear regression that's better, go back and get the linear equation by doing the lin reg. How are we feeling about this?
Pretty good.
Good? Okay. Really, really bad. I'm lost.
Hey, how you doing?
Can I get a vote from everyone about how they're doing? Because that would definitely help me with kind of seeing where we're at. Okay. So, if you have questions, please ask. But this relates very similarly to what we did back in chapter 1. Yes, Nate? The gift? I'll be there in a second. Page 77, 21 through 24, 26 through 30.